Hello students, myself Sir Pratap Singh. We would be starting organic chemistry class 12th, the first chapter Haloalkanes and Haloarenes today, and this is an introductory class. Here we would be discussing about introduction, classification, usage, nomenclature, isomerism, like physical properties, like some basic topics of this chapter. Okay. So first of all, we need to understand haloalkanes and haloarenes and related terms. Fine. Okay, let's start. We are going to explore what is meaning of alkyl halide. Alkyl halide, simply as the name suggests, there is alkyl, when there is an alkane, and if you remove one hydrogen from alkane, you get alkyl. Let's give you example of alkane like C2H6. Fine. If you okay, let's explore the structure of this. Fine. Let me remove any hydrogen. This is alkane. This is alkyl. Alkane, alkyl. And if I put any halogen over here, this is alkyl halide or haloalkane. Anyway, very simple thing. What to do? Alkyl halide is halogen derivative of alkane, or we can also say when halogen is directly bonded to sp3 carbon of aliphatic systems. When we say aliphatic, halogen directly bonded to sp3 carbon is okay. Aliphatic means open carbon chain. Fine. Okay, again sp3 carbon, aliphatic system, open carbon chain. So any halogen attached to it, that would be called alkyl halide or haloalkane. Simply they can be represented as Rx. Okay, Rx. Here R is alkyl, so they can also be written as CnH2n plus 1x. Here, while we are talking of X is F, Cl, Br and I, like halogens. Okay. So this is alkyl halide. We can think of any other alkane. We can remove these hydrogens, these hydrogens, these hydrogens, these hydrogens, and we put the halogen anywhere. That would be called alkyl halide. These alkyl halides have different subtypes like primary, secondary, and tertiary. From class 11, you have to understand what is meaning of primary, secondary, and tertiary. Primary carbon means carbon which is further attached to one more carbon. Correct? Further attached to one more carbon. This is primary carbon. So there are two hydrogens attached and this is X. So what is this? Primary carbon attached to one more carbon. So remaining valencies are hydrogens and this is the halogen. Okay. So primary is R, C, H, H and then X. Simply I can say RCH2 X. If I go for secondary, it would be like, there are two alkyls, they may be same or different. So like R2 CH X or R C R dash H X R dash C H and X. Fine. Here what you see? R C X H and H. Tertiary. Here simply, if this carbon is attached to 3 alkyl groups, this is 3 degree. So like this, R3CX or RC R dash R double dash X. Okay, what do you see there? Carbon attached to 2 hydrogens, carbon attached to 1 alkyl and then 1 halogen. Carbon attached to 2 carbons, 2 alkyl, then attached to 1 hydrogen and 1 halogen. Carbon attached to 3 alkyls, 1, 2, 3 and then 1 halogen. 1 degree carbon, 2 degree carbon, 3 degree carbon. Primary, secondary, tertiary alkyl halides. Correct? Fine, this is very simple thing, like what type of alkyl halide is this? 1 degree, 2 degree or 3 degree? This is 1 degree because this bromine is attached to a carbon which is further attached to 1 more carbon. So this is 1 degree carbon, so this is 1 degree alkyl halide. Correct? Now let's further talk about allylic or benzylic. These are also types of alkyl halides. Allylic. When obviously these are types of alkyl halides. Whenever halogen is directly attached to sp3, this is allylic. Okay. So how do we define that? Halogen directly attached to sp3 carbon which is adjacent to a double bond system. Okay. Benzylic. Halogen directly attached to sp3 carbon which is adjacent to a benzene ring. Fine. Here 2 valencies remaining. That means they can be 1 degree, 2 degree or 3 degree. Like if I put hydrogens over there, 1 degree. If I put 1 hydrogen, 1 carbon, 2 degree. If I put both carbons, 3 degree. Correct. Same thing here. So allylic and benzylic can be 1 degree, oblique 2 degree, oblique 3 degree. Fine. If somebody asks me what is allyl chloride, okay, let me tell you one more thing. This position itself is a allylic position. What is the position is that? The carbon adjacent to double bond, that position is called allylic. Okay. Now, simplest allylic system would be CH2, put both hydrogens over there, hydrogen, hydrogen, hydrogen. Okay, this is simplest allylic system. HH, 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 and X is the Cl here. So this is allyl chloride. This is simplest system. IUPAC name. Interesting thing to observe. There are 3 carbon system. We can count from here numbering or from here. From here double bond would be at priority. From here halogen would be at priority. Now as the name suggests, haloalkane. Haloalkane. What does that mean? Halogen is taken as a branch or substituent all the time. Correct? So if you have to decide the priority among them, this would be at lesser priority. So 1, 2, 3, 3 chloro. 3 chloro. Propene. You can write 3-chloropropane. Okay. Allyl chloride. Similarly, benzyl So simplest benzylic system would be benzene HH. Correct. So the name would be benzyl chloride. Simplest system. Obviously this is 1 degree again, this is 1 degree also. IUPAC name is chlorophenyl methane. This is derivative of methane, 1 Cl and 1 phenyl. Okay, so the name is chlorophenyl methane. Chloro comes first because of alphabetic thing. Okay, alphabetically it is at higher priority. Okay, fine. So this is simplest allylic system, this is simplest benzylic system. Now let's give you one example. Finally, this is benzylic position, correct? This position is not benzylic, this position is allylic, double bond adjacent to double bond. This is allylic position. This is benzylic position, this is allylic position. This position adjacent to double bond, this position is also allylic, this position is also allylic, benzylic, and now degree, this carbon 2 degree allylic, this carbon 2 degree allylic, this carbon 2 degree benzylic. So how are we deciding degree? On the basis of number of carbons attached. Benzylic since adjacent to benzene, allylic since adjacent to double bond. Now vinylic and arylic halide. Okay. Aryl halide is very simple. Halogen directly bonded to aromatic ring. Like bromobenzene, that is phenyl bromide. This is common name, phenyl bromide. Since halogen is directly attached to aromatic ring, they are called aryl halides, and IUPAC name is haloarenes. They are also called nuclear halogen derivative. You can guess that why. Yeah, because they are directly attached to the benzene nucleus. Vinylic, something like this, halogen directly attached to double bond system. Simplest example is HHH, vinyl chloride, and you know its IUPAC name chloroethane. You know, we can call these vinylic things as haloalkanes. We can call them alkynyl halides. Types, alkynyl halides, haloalkanes, there are types of that, and this is simplest example. Go through these terms: haloalkane, alkynyl halide, vinylic halide, halogen directly bonded to a doubly bonded system, halogen directly bonded to aromatic ring. So now again, Allylic benzylic. Difference: halogen directly attached to carbon which is adjacent to double bond. Halogen directly attached to carbon which is adjacent to benzene ring. Vinylic, halogen directly bonded to carbon which is doubly bonded. Aryl halide, halogen directly bonded to aromatic ring. Primary, secondary, tertiary, allylic, benzylic, vinylic, arylic. Now let's talk about dihalogen derivatives. Geminal 1,1, geminal or 1,1 or alkylidene halides. It's like something like that. This is geminal. Okay, same halogen repeated on the same carbon twice. Example: CH3CHCl2. It would be called ethylene chloride. Vicinal 1,2. Alkyline dihalides. Example: something like this. Halogen repeated on adjacent carbons. For example, CH2, Cl, Cl. Ethylene dichloride. Geminal, halogens are repeated twice on the same carbon. Halogen repeated twice on the adjacent carbons. Alpha omega dihalide halogen attached to first and last carbon of parent chain. Alpha and omega are for first and last carbons of carbon chain. So any such example, like if we start, at least 3 carbons would be there. It is a type of alpha omega dihalide 1,3-dichloropropane. So we have covered geminal, vicinal, alpha omega dihalide. We have covered primary, secondary, tertiary, allylic, benzylic, vinylic, arylic. We also have some other types which we may discuss, like if somebody says, what is cycloalkyl halide? It can also be called halocycloalkane. For example, cyclohexyl bromide, or better you call this bromo cyclohexane. The next type is other alkyl halide. This is also called side chain halogen derivative. Here halogen is indirectly attached to aromatic ring. For example, benzene CH2 Br. That is, halogen is indirectly attached to aromatic ring. Now, if somebody asks you what is alkynyl halide, halogen directly attached to alkyne. Haloalkane. If there are talks about monohalogen derivative types, we can discuss primary, secondary, tertiary, allylic, benzylic, vinylic, arylic. These are all monohalogen. These are dihalogen derivatives, geminal, vicinal, alpha, omega. These are some other types: cycloalkyl, aryalkyl, alkynyl halide. Okay. Extra topic. Bridgehead systems. You must have learnt about this in class 11th. So there can also be bridgehead, primary, secondary, tertiary alkyl halides. Correct? We will discuss this later. So this is introduction and classification related to haloalkanes and haloarenes. Now this is page 3. This was page 1. Nomenclature we have already dealt in class 11th, I think. So that would not be a problem. But isomers we have also drawn in class 11th. Okay. But let's go through it again. C3H7. This is propane, correct? Propyl, we can remove hydrogen from here or here. For example, let's put Br here. So this is called NPR Br. N propyl bromide or 1-bromo propane. This can also be called IPR Br, isopropyl bromide. 1, 2, 3 numbering, 2-bromo propane. So there are two isomers of this, first and second. What is the relation between them? 1, 2, 3, 3 carbon chain, 1, 2, 3, 3 carbon chain. Position of Br is different. These are position isomers. Now let's talk about C4H9. First C4H10. Butane, isobutane, that is also called 2-methyl propane. From here we can remove hydrogens from first carbon. These two are identical, or we can remove hydrogens from second carbon. These two again are identical. So first isomer we can do this from here. Second hydrogen we can remove from here or here. CH3, CH2, CH. Let's put Br here. This would be called NBuBr, N-butyl bromide. This would be called not N, but this would be called secondary butyl bromide. N-butyl bromide, secondary butyl bromide. IUPAC name 1-bromobutane, 2-bromobutane. Okay, iso. Remember this thing. This thing is called iso, not psycho. Iso. CH3, CH, CH3. Further attached. Okay. N. Somewhere you read N is straight chain. Sorry, not straight, but N is straight or whatever, unbranched chain. Okay. Like even if it is not so straight, it is unbranched. So it is N, normal chain. Okay. N, normal chain, straight, unbranched. Iso, you see this iso thing, secondary 2 degree. 2 degree. What is degree of this thing? 1 degree. What is degree of this thing? 1 degree. What is degree of this thing? 2 degree. Now you may be asking why it is not called secondary. Maybe it is possible to call it secondary, not a problem. Okay, its most common name is used, iso, but it cannot be called iso. It is secondary only. Iso, to for it to be iso, there should be 2 CH3 attached to this carbon, like here, 2 CH3. Now we go for third option. We can remove hydrogen from here. You can also remove hydrogen from this carbon. Yeah, this is iso, isobutyl bromide, iso, CH3, CH, CH3. This is 3 degree. This is tertiary butyl bromide. This is 3 degree. 1 degree, 2 degree, N, secondary, tertiary, and this is iso, degree is 1 degree. Okay, let's listen to this. 1 degree, 2 degree, 1 degree, 3 degree. Done. N, straight chain, it's also called primary, secondary, iso, tertiary. 1 and 2, how are they related? They are 1 and 2, they are chain isomers. 1, 2, 3, 4, 1, 2, 3, 4. Sorry, position isomers. Position isomers. Again 3 and 4, 1, 2, 3, 1, 2, 3, methyl Br. Br, position of Br is different. 3 and 4. Position isomers. Now let's talk about 1 and 3, 2 and 3, 1 and 4. Like any of these two, any of these two. So they are having different chains. 4 carbon chain, 3 carbon chain. So 1 and 3, 2 and 3, 1 and 4, 2 and 4. Different pair of chain isomers. C5H11 you have to try. first you have to think about isomers of pentane, its parent, N-pentane, isopentane. It's also called 2-methyl butane, neopentane. So 3 isomers of pentane. Now we have to draw pentyl. Okay. Okay. Can you suggest how many pentyl should be there? We can remove hydrogen from here. 1, 2, 3. Here identical. Here identical. 1, 2, 3, 4. This and this identical. Here anywhere identical. You can not remove hydrogen from this position. So 1, 2, 3, 4, 5, 6, 7, 8. Total 8 isomeric pentyl. This is a question solved in NCERT. I have given you the idea. You have to remove hydrogen from here or here, or here, 4, 3, 7, or anywhere. Okay, so you'll get 8 isomers. Try yourself, and after that also give the name. Give IUPAC names. As you have observed, haloalkanes exhibit chain isomers and position isomers like 3 and 4. Position isomers, BR position is different. 1 and 2 position isomers, 1 and 3 different chain isomers. Haloalkanes chain and position isomerism. Yes. There are also other isomerisms possible in some cases. Geometrical isomerism. In class 11th we have learned that for geometrical isomerism, general idea is there is a double bond, two valencies, DE, DE. So it can exhibit geometrical isomerism. These two different geometrical isomerism possible. These two different GH. These two different geometrical isomerism possible. So these two groups must be different. Okay, there is no relation between the here and here. Whatever groups are there, those two must be different. These two must be different. In that scenario, you can say they can exhibit geometrical isomerism. Like this is cis isomer. This is trans isomer. Okay, how many carbons are there? 1, 2, 3, and one position there is Cl, and one position there is in. So the name is 1 chloro propene. it has cis and trans isomers. One chloropropene, cis and trans isomers. So geometrical isomerism is possible in haloalkene. Possible. There are also vinylic. Haloalkene means vinylic. Sorry for that. So now geometrical isomerism is possible, but there must be a double bond. So that would be possible only in case of haloalkanes or vinylic halides. There are possibilities of cis and trans isomerism, and since cis isomer would involve both hydrogens on the same side, trans isomer would involve both hydrogens on the different side. Now let's talk about a question related to that. What about dipole moments of these? Okay, so if you talk about CH3 is electron releasing group, Cl is electron withdrawing group. So if I draw something like this is electron releasing group, see that, and this is electron withdrawing, this is H, this is H, you see that, releasing, withdrawing, and here electron releasing group, and this is electron withdrawing. So what do you see there? There the vectors are added in the same direction. So trans isomer has greater dipole moment, and since it is more polar, hence it has higher boiling point. More polar would involve higher dipole-dipole attraction. Greater attraction would cause greater boiling point. Optical isomerism. There are various types of possibilities of optical isomerism, not only one. But the most basic type would relate to chiral carbon. If I say chiral carbon, the carbon which is attached to 4 different groups. So for any molecule to exhibit optical isomerism, there should be the carbon attached to 4 different groups. Like if we start from simplest thing, we can put one hydrogen here, we can put one halogen here, we can put minimum number of carbons, that is 1 here, but we would have to go for CH2, CH3 here. So this is the simplest haloalkane which can exhibit optical isomerism. This carbon is chiral carbon. Chiral carbon, you know well from class 11th, sp3 carbon attached to 4 different groups. In such a case, there would be 2 optical isomers, dextro and levo. They are also called pair of enantiomers. So this phenomena is also called enantiomerism. In other words, question can be asked that which of the following can form racemic mixture? 50% mixture of dextro, 50% mixture of levo is called racemic mixture. Now again I am telling you, optical isomerism requires presence of chiral carbon in general. Okay, it's not always that. Chiral carbon means attached to 4 different groups. So this is the simplest haloalkane we have done there. And for the molecules having one chiral carbon, there would be 2 types, dextro and levo, both optical isomers. So the phenomena is called enantiomerism, as they are also called pair of enantiomers. And 50% dextro plus 50% levo form it taken together in a mixture that is called racemic mixture. Now let's come back. I am telling you one thing. If you are drawing the isomers of here, total 8 isomeric pentyl. So here we were talking about only structural isomers. both geometrical and optical are covered in stereoisomerism. Generally, when we are asked about isomerism, we generally forget about stereoisomerism. But whenever they say find number of isomers, you have to include even the geometrical and the optical. Whenever they say find structural isomers, obviously, then you can, only find number of structural isomers like chain isomers, position isomers, etc. So stereoisomerism involve geometrical, optical plus conformational, but let's just focus on geometrical and optical. This is the formula given C7H7Cl. We have to draw the ice. Okay, what is the name of this thing? 1, 2, 3, 4. These 4 carbons, and we have read about this earlier. This is secondary butyl halide. Secondary butyl halide. Benzene CH2Cl. This is the first isomer. I hope you remember this. Benzyl chloride, benzene Cl CH3. This is ortho chloro toluene. Then again meta isomers, para isomers. Ortho, meta and para, these are position isomers. Like this is orthochlorotoluene. We can also say like this is the position 1, this is position 2. 2-methyl chlorobenzene. But this is obviously out of these two, Cl is at high priority, so this is position 2, 2-methyl chlorobenzene, or just orthochlorotoluene. If you can put ortho meta para, meta isomers, para isomer. Okay, if you put Cl anywhere and CH3 is at 3 position to it is meta isomer. If you put Cl anywhere and CH3 is at 4 position to it is called para isomer. One, two, three, 4. Here ortho meta para. This is benzyl chloride plus. Is there any other possibility? I think no. So 4 benzenoid isomers. So what is meaning of benzenoid here? I think you can get it very well. Benzenoid means benzene containing rings. Okay. Note. C6 H3Br3. How many isomers? Br. This is like 1, 2, 3. One, two, 4. One, 3, 5. 3 isomers. Okay. 3. And how are they related? Position isomers. Okay, that's it. we have covered classification, nomenclature and isomerism. In next class, we would be discussing about physical properties and important compounds and uses. From the third lecture onwards, we will be starting preparation and properties. That is the most important part of this chapter. Okay, I would provide you homework in the next video. Till then, take care. Thank you.